So we are group 10. Our project was called Roach. My name is Cole Bayer,
Ian Scott.
Russell Chapman.
and David can't be with us tonight. From spreading harmful diseases to causing severe allergic reactions, cockroaches are not merely pests, they are creators of chaos and destruction, undermining our peace of mind and the integrity of Arizona State University. So a little bit about the background of our project. Many students at Arizona State encounter cockroaches frequently, not only on the Palm Walk, but anywhere on campus. Palm Walk is just a little bit more concentrated with the cockroaches. We were trying to design a robot that can efficiently rid Palm Walk and campus in general of cockroaches. And the reason for that being that no autonomous solutions currently exist on the market, so ours would be the first. So our buyers are going to be the university. We don't expect students to buy our robot because it's pretty expensive. But the students are definitely the end users. Anyone living on campus will benefit from our product because they'll see less cockroaches. And then some other people that may affect the design indirectly are students, staff, and pretty much anyone who's going to be walking on the same sidewalks that our robot is going to be driving on. So we interviewed a variety of different customers. Most of them were students here at ASU, and the general questions we asked them were, do you see cockroaches here at ASU? Do you like seeing cockroaches here at ASU? And would you support us removing them? And majority of them said they see cockroaches, they don't like them, and they would like them to be removed. So that gave us the demand for our product, and that's why we're still doing what we're doing. So our design requirements were to detect cockroaches within 10 feet of the ultrasonic distance sensor, eliminate cockroaches, and it should work from 11 a.m. to 5 p.m. uninterrupted. It should be able to avoid any form of life that's not a cockroach, and it should also be able to traverse various different types of terrain. So sidewalk, pavement, dirt, grass. We were also trying to have a kill-death ratio on the cockroach robot, but that didn't end up happening. So in the final design, we'll look to have the KD.
All right, so for our mechanical design, so the distance sensor is what lets our design know when to turn. And the way our robot turns is by two of the front wheels on one side accelerating, while two of the back wheels on the other side going in reverse in order to turn it. And our hammer is swung using a servo. Everything is powered by 9-volt batteries. And one thing we changed to our design from the cab model is we added an extra pair of wheels to the design because 4 wheels just weren't enough to turn and steer it and all that.
So for our circuit, we have 7 9-volt batteries, an Arduino, 6 hobby gear motors, breadboard, 3 L298Ns, 25 kg servo, and a distance sensor. So on the right, you can see our Tinkercad model. This is our original model, like what it's supposed to be like. It's very clean, less cluttered. And then obviously on the left is our actual circuit. The one on the right, it just wasn't enough power, obviously, and like it's just our like prototype kind of. So basically on our actual circuit, the Arduino just sends the signals to everything, tells it what to do. With the L298Ns control the motors, and they're powered by 2 9-volt batteries each, and then there's 1 9-volt to power the servo, which is also controlled by the signal from the Arduino. And then for the software, it's very simple code, pretty much. The robot just goes until it senses an object and then it turns to the right. And then obviously since another object, it just keeps turning until it has a path. And then the servo controls the hammer and it just smacks the cockroaches. Pretty simple. So the servo code is the one on the bottom left, and that just tells the hammer to go up and down 90 degrees to 0 degrees, 90 degrees, 0 degrees. And then the code in the middle is basically just all like declaring the outputs and inputs, as well as the on the bottom there is the distance sensor code. And then on the far right you have the code for the motors, which tells them to keep going forward when when the distance is greater than 20. And then when the distance gets less than 20, it turns to the right, which it basically just tells all the wheels on the right to go in reverse and the wheels on the left to go forward.
All right, and here is a quick demonstration of our robot moving around.
Yeah. So for our prototype materials, we just had the Arduino Uno Super Starter Kit, which we were provided in class. We used the L298N motor drivers for all of our DC motors. And then we also had a 25 kilogram servo in anticipation of actually having to smash real cockroaches, which we never ended up having to do. If we were to have to develop a final design, though, based on our final prototype, it would be roughly around $200 just due to higher quality parts and wheels that would be able to support the full weight of the robot. And our prototype, we wanted it to be able to go over different surfaces in various terrains, but it could pretty much only go over a smooth surface. Any bump would throw it a bit off course. So yeah, we'd be looking to pretty much double our total of $76 to around 150 or 200 if we were to make a final design.
All right, I've got the time at 6.5 minutes, just so you know. All right. So for our start, we really just learned about wiring and coding and built our prototype based on what we knew. And then past the proposal presentation, we really started brainstorming materials, getting everything together, planning, making our CAD model. And then we set to making the actual final design and setting the final coding and doing final revisions.
So for the entrepreneurial aspects, other like similar things in the market, there's really no product that's quite like ours. And then competitors, there are other things that eliminate cockroaches like traps and exterminators, of course. Ours is more expensive than most things on the market, with the exception of exterminators, but we're the only one that's autonomous. Why our product is something you should invest in. Our product is innovative and autonomous, and it does the job well. It humanely and effectively kills cockroaches. Some feedback that I received from one of our interviewees, Jose, he said it doesn't effectively sense the cockroaches and the hammer doesn't consistently swing down when it's supposed to. That was the main complaints he had with it. To summarize everything, the most important things we learned were like the basic skills of how to code an Arduino, the different motors and sensors we learned about, CAD modeling, how to create an effective circuit. We learned that you need a lot of power. We just kept adding 9 volts. And then the biggest takeaway was identifying issues within the robots, because a lot of times you take it to either like the engineering center, peers, or even TAs, and they wouldn't be able to identify the issues with our robot. And that was like one thing we struggled with. And we spent class periods just doing that. And it's one of the biggest things we learned to do. What would we do differently? Well, we 3D print earlier so we could get the hammer better, or maybe even the body as well, but I'm not sure that we would have changed the body. Get a different servo. The servo, it seemed effective when we bought it, but it was very difficult to code and it never really worked out. We have to find an effective way to sense the cockroach because we never really did that, and it was very difficult. We'd also make like our design or like the presentation of our robot look better. It didn't really look great. It was just kind of open and wood. And yeah, that's pretty much everything. This is just our augmented reality. It's just our 3D model, and it works.